A city, suffocating under the weight of its own success, once contemplated an impossible solution to an intractable problem, burying an entire highway beneath itself. Not a mere underpass, nor a simple tunnel connecting two distant points, but an entire urban freeway system. This colossal feat of engineering would plunge deep into the earth, weaving its complex network beneath active streets, towering skyscrapers, vital metro lines, and even beneath the very rivers that define the city's geography. Millions of lives would continue above, oblivious to the monumental endeavor unfolding in the bedrock below. The notion itself seemed reckless, an audacious gamble against the very laws of urban planning. When engineers first unveiled the concept, skepticism filled the room, a palpable wave of doubt washing over the assembled experts. Yet the alternative was a slow, agonizing demise. This city was not merely experiencing traffic, it was experiencing a systemic circulatory collapse. The congestion was not a temporary inconvenience, but a permanent state of paralysis, akin to a vital artery completely occluded. This was not the sporadic snarl of a holiday weekend. This was the relentless, suffocating reality of every single morning, every afternoon, every night. The surface road network, a relic built for a bygone era, now groaned under volumes it was never designed to bear. Commute times, once manageable, had first doubled, then tripled, stretching the fabric of daily life to its breaking point. Freight trucks, the lifeblood of commerce, sat idle for hours on corridors meant to be arterial routes, their engines spewing fumes into the stagnant air. Emergency vehicles, ambulances, fire engines, first responders found themselves trapped in an endless gridlock, losing critical minutes that often meant the difference between life and death. Neighborhoods adjacent to these choked transit corridors were strangled by through traffic with nowhere else to go, their once vibrant streets transformed into relentless rivers of metal. The roads were full, the air was thick, and yet the city continued its relentless expansion. Urban planners, armed with every conventional tool, had tried everything. They widened intersections, synchronized traffic signals across hundreds of junctions, added dedicated bus lanes, implemented ramp metering systems, and introduced variable speed limits. They constructed flyovers, rerouted freight, and optimized every conceivable flow. But none of it was enough. The fundamental problem transcended the design of individual roads. It was a crisis of sheer capacity. In a dense, built-up metropolis, capacity cannot simply be conjured from thin air. Every proposed surface expansion meant the demolition of buildings, the displacement of communities, the fragmentation of neighborhoods that had taken generations to coalesce. The political cost alone had doomed countless projects before they even reached the drawing board. It was then that the core question shifted from how do we add more road to where do we put it? And the answer, emerging slowly, controversially, and at astronomical expense, was a radical proposition. Underneath. This was the only remaining frontier, a subterranean canvas where the city could finally breathe, creating a hidden world of movement beneath the very foundations of its existence. It was a testament to human ingenuity, born from desperation, a gamble that would redefine the relationship between a city and its relentless pulse. The city above hums with life, a ceaseless current of vehicles and pedestrians flowing across its arteries. Most who traverse these bustling streets remain utterly unaware of the hidden world beneath their feet, the silent monumental struggle waged deep within the earth. For years beneath this very pavement, An elite cadre of engineers meticulously scrutinized every single centimeter of ground, mapping the subterranean landscape with an obsessive precision. The audacious concept of an underground highway, a subterranean lifeline, was not a sudden revelation. It was forged in the crucible of relentless data, emerging from countless hours of sophisticated traffic modeling, exhaustive urban planning reviews, and rigorous engineering feasibility studies. Teams of transport specialists embarked on an unprecedented endeavor, charting the city's intricate traffic flows with microscopic accuracy. Their analysis extended far beyond simple daily averages. It delved into the furious rush of peak-hour movements, the heavy arteries of freight corridors, the critical pathways for emergency services, and the complex, interwoven patterns of cross-city commuter journeys. From this ocean of data, a stark, undeniable truth crystallized, a vivid, three-dimensional portrait of where the urban pressure was most acute, where the city's very breath was being choked. The data revealed precisely where a high-capacity underground route could offer the most profound, most transformative relief. The proposed alignment, a bold stroke of engineering ambition, was destined to carve its path directly beneath the city's most relentlessly congested central spine. It would be a colossal undertaking, roughly 11 kilometers of twin-bore tunnel designed to carry 2 lanes of traffic in each direction, a subterranean river of steel and light. This colossal artery would plunge to extraordinary depths, oscillating between 18 and 34 meters below street level. The precise depth at any given point was dictated by the unseen obstacles lying in its path, a labyrinth of existing infrastructure that had to be navigated with surgical precision. At these profound depths, the new tunnels would weave their way beneath the colossal foundations of towering office blocks, the dense networks of residential complexes, the sprawling footprints of bustling shopping centers, and at several critical junctures, they would pass perilously close to active metro tunnels, arteries of transit already thrumming with life, running precisely within the same constrained corridor. This was where the true complexity began to reveal itself. The geological tapestry beneath this vibrant metropolis was no engineer's dream of clean, unyielding rock. It was not the simple, stable bedrock that tunnel builders pray for. Instead, the upper layers presented a treacherous cocktail, a shifting mosaic of soft alluvial clay, fine sandy soils, and unstable reclaimed fill. This was not inert earth. This was material that possessed an unsettling plasticity, a tendency to move, to flow, to betray its position the moment it was disturbed. Get the pressure wrong inside a tunnel-boring machine, and this treacherous ground would surge towards the cutter head with the relentless force of water, threatening to engulf the colossal machinery. And directly above this volatile, unpredictable ground sat billions of dollars worth of vital infrastructure, buildings, utilities, and existing transit lines, none of which could be permitted to settle by more than a few precious millimeters. Before a single construction contract was even contemplated, before the first shovel broke ground, engineers commissioned an exhaustive, unprecedented ground investigation program. Across the entire length of the proposed alignment, hundreds of boreholes were meticulously drilled, piercing the Earth's crust to extract its secrets. Soil samples were subjected to an array of punishing tests, analyzed for their sheer strength, their permeability, their consolidation behavior under immense pressure. The subterranean water table, a hidden ocean, was mapped with intricate detail at multiple depths, its ebb and flow crucial to understanding the ground's stability. Every buried utility, every gas main, every water pipe, every high-voltage electrical cable, every delicate telecommunications conduit, every vital drainage system was painstakingly located and cataloged. This vast trove of data was then fed into a sophisticated three-dimensional underground model, a digital ghost of the city's hidden depths, which grew exponentially more detailed, more precise, with every additional survey point. What this model ultimately revealed was nothing short of daunting. The subterranean corridor beneath the city was not merely congested. It was, without exaggeration, one of the most densely packed, most complex underground environments imaginable on the planet. A hidden world of intertwined systems, each vital, each fragile, each demanding an almost impossible level of respect and precision. And it was through this invisible, intricate web that a new, transformative path had to be forged, a testament to human ingenuity against the silent, unyielding forces of the earth. Beneath the city's ceaseless hum, a hidden world of immense complexity lay waiting. For more than a century, layers of vital utilities had been woven into the urban fabric, installed, upgraded, moved, and reinstalled, creating an intricate, almost impenetrable subterranean tapestry. Below this, two separate metro tunnels carved diagonal paths, intersecting the proposed alignment at critical junctures. And then, the river itself, a crossing where the water table pressed against the surface, leaving a mere 8 meters of fragile earth between the riverbed and the planned tunnel's crown. The natural inclination might be to seek an easier path, to curve the route, to skirt the most formidable obstacles, to simply go around. But the very essence of this ambitious highway project was its unwavering commitment to the city center. Any deviation, however slight, would pull it away from the pulse of the urban core, diminishing its purpose, severing its connection to the very traffic it was designed to carry. Every single departure from the optimal alignment would erode the project's effectiveness, rendering it a compromise. The engineers understood this fundamental truth. They were compelled to confront the unforgiving ground, not evade it. Here, at one of the vast launch sites, the colossal tunnel boring machines, each a marvel of engineering, were meticulously assembled. These leviathans of steel and power were then lowered into position, descending into a cavernous pit, plunging some 22 meters deep into the earth. Once operational, these mechanical giants could advance at a steady pace, carving out 12 to 14 meters of new tunnel each day. Yet as they approached the delicate live crossings of the metro lines, their relentless progress slowed to a crawl. Crews worked with an almost surgical precision, monitoring the ground in real time, every vibration, every subtle shift, scrutinizing every millimeter of advancement. The control center stands as the unwavering nervous system of this entire 11-kilometer underground artery. It operates without pause, 24 hours a day, a silent sentinel staffed by dedicated operators. Their gaze is fixed upon a constellation of live camera feeds, intricate sensor dashboards, and a constant flow of traffic data. This is where vigilance meets technology, where human insight merges with automated intelligence. The very instant a vehicle falters within the tunnel's embrace, whether due to a sudden breakdown, an unforeseen collision, or any other anomaly, the system registers it with startling speed. A sophisticated combination of automatic incident detection algorithms meticulously analyzes the camera feeds. Loop detectors, subtly embedded within the road surface, signal a disruption. Overhead radar sensors, designed to track expected speeds, register a sudden, telling absence of data. The response protocol is not merely swift, it is immediate, a perfectly choreographed sequence of actions, variable message signs, strategically placed throughout the tunnel, instantly illuminate, alerting approaching drivers to the unfolding situation ahead. Above the relevant lane, crimson crosses flare to life on the lane control signals, directing traffic away from the incident. Operators, their eyes fixed on the live camera feeds, assess the scene with trained precision. Within moments, the tunnel's own rapid response vehicles are dispatched, hurtling from dedicated stations positioned at both portals. Simultaneously, external emergency services receive immediate alerts. The target, a testament to meticulous planning and training, is to have an emergency vehicle entering the tunnel in under 4 minutes from the initial detection of an incident. Beyond the immediate concerns of traffic flow and safety, the tunnel's very integrity is safeguarded by an advanced flood protection system. The portals, the gateways to this subterranean world, are meticulously engineered with carefully calculated grades. They slope both inward and upward, a subtle yet critical design feature, ensuring that torrents of surface water, unleashed by heavy rainfall, cannot simply cascade into the tunnel's depths. At the lowest points of the system, a network of robust drainage channels converges, feeding into powerful pumping stations. These stations are equipped with redundant pump sets, a fail-safe mechanism guaranteeing continuous operation even in the face of extreme conditions, a silent promise that the city's vital artery will remain uncompromised, flowing even as the world above endures its storms. This intricate dance of engineering, of foresight and unwavering vigilance, ensures that the seemingly impossible task of threading a highway through the city's very foundations remains a triumph of human ingenuity. Beneath the relentless pulse of the city, a hidden world of engineering marvels protects the subterranean arteries of traffic. A sophisticated drainage system stands ready, equipped with both primary and backup capacities. It is engineered to manage inflow rates far exceeding anything even the most catastrophic storm event could conceivably unleash, a testament to foresight against nature's fury. This intricate network also confronts a more insidious challenge: the small yet ceaseless ingress of groundwater, an inevitable consequence of any deep tunnel construction. The very concept of waterproofing in such an environment is a layered philosophy, a multi-tiered defense against the persistent pressure of the earth itself. The precast concrete segments forming the tunnel's robust lining are not merely poured, they are meticulously crafted. Their water-to-cement ratio is controlled to the second decimal place, a level of precision that yields an extraordinarily dense, low permeability concrete, a first line of impenetrable defense. Each segment ring, once formed, receives an external coating, a high-performance sheet, waterproofing membrane, meticulously applied to create an unbroken barrier. The critical junctions where these colossal segments meet are sealed with resilient rubber gaskets, strategically placed at every joint and reinforced at specific, geologically sensitive points along the alignment. Even then, a contingency exists: a secondary injection port system, a network of hidden conduits, allows for the precise injection of specialized grout directly into any joint from within the tunnel. Should the slightest hint of seepage ever manifest across the road's operational lifespan, it is a vigilant, self-healing mechanism built to endure for generations. The true marvel, however, lies in the execution of this monumental undertaking. The sheer scale of the project, the relentless boring through bedrock, the meticulous lining and waterproofing, the intricate installation of ventilation systems, the construction of the multi-lane road deck, the complex underground ramp works, and the seamless integration of control systems, all transpired while the vibrant metropolis above continued its daily rhythm, completely undisturbed. There were no partial closures, no widespread diversions, no significant disruption to the city's ceaseless flow. Construction teams moved with the precision of a choreographed ballet, working in carefully sequenced zones. Utility diversions, a monumental task in themselves, were completed section by section. Long before the tunnel-boring machines even began their subterranean journey, gas mains and water pipes lying along the tunnel's projected path were meticulously relocated, establishing safe clearance distances well in advance of the TBM's arrival beneath them. A silent, unseen watch was maintained over the city's foundations. Settlement monitoring pins, tiny sentinels, were installed on every single building within a 50-meter corridor along the tunnel's alignment. Each week, every single reading from these pins was rigorously assessed against predefined movement thresholds. It was a constant, almost imperceptible tremor of vigilance. Then, 9 months into the drive, a critical alarm. A historic Victorian block of buildings, its foundations rooted in the city's past, began to show ground-floor settlement, inching perilously close to its alert level. Immediately, decisively, construction paused. Engineers initiated a delicate surgical intervention, injecting compensation grout beneath the distressed foundations, a slow, controlled counterpressure. For over 72 agonizing hours, the response was meticulously monitored, the city holding its breath before the colossal machines were permitted to resume their work. Deep within this subterranean labyrinth lies another feat of engineering: the underground interchange areas. These are not merely junctions. They are vast, multi-level caverns, buried 30 meters beneath the bustling streets. The geometry within these spaces is nothing short of extraordinary. Ramps curve and spiral through solid rock, twisting and descending in ways utterly invisible to anyone traversing the surface above. These subterranean interchanges proved to be among the most complex elements of the entire project. Connecting an 11-kilometer deep highway to the surface road network is far more than simply carving openings for ramps. It demands an intricate understanding of traffic flow, structural integrity, ventilation, and emergency protocols, all woven into a three-dimensional tapestry of concrete and steel, hidden from the light. This hidden world, a testament to human ingenuity and relentless precision, functions as a silent, vital organ beneath the city's skin. It is a constant reminder that beneath the visible, the familiar, lies an unseen realm of meticulously engineered solutions, silently safeguarding the flow of life above. The ground beneath our feet holds secrets and challenges. To carve a path through its ancient stone, to guide the relentless flow of modern traffic, demands an understanding of forces both visible and unseen. Every curve, every gradient, every inch of concrete must be engineered to work in harmony with real vehicles operating at real speeds. Proper sightlines, safety separation distances, appropriate lane widths, and gradient limits that even the heaviest vehicles can safely manage are not mere suggestions. They are absolute imperatives. Yet deep beneath the surface, each one of these meticulously calculated parameters encounters an unyielding adversary: the geology itself and the intricate, often forgotten labyrinth of existing buried infrastructure. Here, the earth dictates the terms, pressing its ancient will against the ambition of human design. Where bedrock resists, or where a century-old utility line cannot be moved, the engineers must adapt, innovate, and overcome. To conquer such formidable constraints, design teams deployed advanced three-dimensional computational modeling. This was no simple blueprint. It was a digital crucible where hundreds of ramp configurations were simulated, tested, and refined. Virtual vehicles traversed unseen tunnels, their trajectories analyzed with microscopic precision, long before a single shovel broke ground. This meticulous process allowed for the exploration of every conceivable angle, every potential compromise, ensuring that the final design was not just viable, but optimal. The engineers ultimately settled on a final geometry where the curved ramp sections employed a minimum horizontal radius of 40 meters. This figure represents a triumph of spatial efficiency, tight enough to thread through the available underground envelope, yet still wide enough to comfortably accommodate the vast majority of trucks and buses that would eventually thunder through its confines. It is a testament to the delicate balance between the raw power of a 20-ton articulated lorry and the unforgiving confines of a subterranean passage. Further reinforcing this commitment to safety and efficiency, the gradients on both the approach and departure ramps were strictly maintained within a maximum of 5%. This seemingly small number is critical. Exceeding it would place undue strain on heavy vehicle engines, escalate the risk of braking failure, and compromise the stability required for safe entry and exit from the deep highway. It is a silent guardian, a physical limit imposed by the laws of physics, ensuring a smooth, controlled transition for every vehicle. Inside the tunnel's vast enclosed spaces, driver perception shifts. The absence of natural light, the monochromatic environment, and the sheer scale can disorient, even subtly. To counteract this, signage within the tunnel adheres to an enhanced standard, far exceeding surface road requirements. Signs are not merely larger, they are significantly more frequent, strategically placed to provide a continuous stream of information. Each sign is illuminated to a higher brightness level, cutting through any potential gloom, creating a clear, unmistakable visual guide that reassures and directs. Beyond the illuminated signs, the very pavement offers guidance. Specialized lane markings incorporate raised reflective pavement markers designed to remain vividly visible even through standing water. This innovation addresses a critical safety concern, ensuring that lane delineation is never lost, even during the heaviest downpours, when spray and glare can otherwise blind a driver to the path ahead. Safety protocols extend to every aspect of the tunnel's infrastructure. Emergency phones are strategically positioned every 150 meters, offering immediate communication in times of crisis. Alongside these vital lifelines, dedicated pedestrian walkways, separated from the roaring traffic lanes by a robust physical barrier, provide a secure route. These pathways are not for casual strolls. They are reserved strictly for maintenance access and, crucially, for emergency egress, a silent promise of refuge should the unthinkable occur. When this colossal undertaking finally opened its gates, after 8 years of relentless planning, intricate design, extensive community consultation, and monumental construction, the impact was immediate. The numbers, cold and impartial, began to tell a story of profound change. Peak hour journey times across the city's most notoriously congested corridor plummeted by an average of 23 minutes in the very first month of operation. This was not just a statistical improvement. It was hours of life reclaimed, stress alleviated, and productivity unleashed for tens of thousands of daily commuters. Freight operators, the lifeblood of the city's commerce, reported an equally dramatic transformation. Overnight delivery runs, which had been painstakingly routed through the tunnel during off-peak hours, were completing on schedules that had remained unachievable for a full decade. The quiet hum of efficient logistics returned, allowing businesses to operate with a renewed precision and reliability. Above ground, the ripple effect was palpable. Surface streets directly above the tunnel alignment, now freed from the burden of tens of thousands of through trips each day, experienced a sharp and immediate fall in traffic volumes. So significant was this reduction that two of the most chronically congested surface intersections were able to be re-optimized. Their signal timing was recalibrated, and for the first time protected pedestrian crossing phases were introduced. A simple yet profound improvement that had previously been considered an impossible luxury. Even emergency service response times in the central zone saw improvement. Not a dramatic, headline-grabbing leap, but a subtle, consistent shaving of minutes. Yet, in the context of a cardiac arrest, the desperate race against a burning building, or the silent horror of a drowning child, those minutes are not small at all. They are the difference between despair and hope, between loss and life. The geometry, designed for real vehicles at real speeds, ultimately became a silent guardian, its unseen pathways weaving a new fabric of safety and efficiency, both above and below the earth. For several months now, the surface world, once a choked artery of steel and frustration, has begun to breathe differently. A subterranean marvel, a tunnel carved deep beneath the urban sprawl, opened its maw to the relentless tide of humanity. Skepticism lingered, a quiet hum beneath the initial fanfare. Could anything truly alleviate the daily gridlock that defined modern life? But now, after a period of observation stretching beyond a mere handful of weeks, the answer is undeniable. Something profound has shifted in the city's very pulse. Where once the relentless crush of peak hour brought a paralyzing stasis, a different rhythm now prevails. Vehicles flow, not in a perfect frictionless ballet, certainly not without the occasional shudder of congestion, but they move. The endless honking, the heavy air thick with exhaust, the collective sigh of resignation, these echoes of yesterday have begun to fade. Below, unseen, the underground highway performs its silent, vital work. It is doing precisely what it was designed to do, transforming the very experience of this metropolis, one journey at a time.